Today we're going to talk about intersections of curves. And so just to look at a couple of pictures here to kind of get in our mind what we're going to be actually solving algebraically in the back. It says create a picture of a circle and a line that don't intersect. So your line doesn't have to be the same as my line. We just need to draw a line somewhere on here where it's not going to touch our circle. So I drew that line, that horizontal line there. Then it says, create a picture of a circle and a line that intersect twice. So again, it doesn't have to be anything fancy. If I draw a line that looks something like that, then we intersect here, and we intersect there. Again, your line doesn't have to be the same as my line. We're just kind of getting an idea of what we're working with here today. If we create a picture of a circle and a line that intersect once, we could have it intersect right here. And sorry about the disorientation of the board, but we're trying to make it intersect only once there, so I was trying to draw a vertical line. Problem number 4. Create a picture of a circle and a parabola that intersect once. Well, a circle and a parabola that intersect once might look something like that. Again, your picture doesn't have to look the same as mine. If we create a picture of a circle and a parabola that intersect twice, then we can draw a parabola like that, and we intersect here and here. Create a picture of a circle and a parabola that intersect 3 times. I'm going to make my vertex of my parabola there at 0, -2. And draw the parabola. And we intersect here at the vertex, and here, and here. There's 3 times. If we want to make a picture of a parabola that intersects 4 times, then let's start below. I'm going to make my vertex here at 0, -3. And then the symmetry I didn't do very well, but we intersect there, 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 and there. That point right there is a little bit off, but there's 4 points. And finally it says create a picture of a parabola and another parabola that intersect 4 times. So I drew the traditional parent parabola here. And then we want it to intersect 4 times. So if we have another parabola with the vertex, say at -3, 2, then we can get a parabola here that intersects 1, 2, 3, 4 times. So that's what we're going to be solving algebraically. We're going to be finding where these curves intersect. And although I didn't do too bad drawing my pictures here, there's some better pictures on 9. X squared plus y squared equals 25 is the equation of the circle there that's drawn on that graph. And y squared equals x squared minus 5 is the equation of the parabola. And what we want to do is we want to find the values of the intersections here on this graph. Well, there happens to be a point right there, which is 0, -5. There's a point here, which is -3, and then 4. negative 4. And then we also actually have a positive here, a positive 3, 4. There are 3 points where those graphs intersect. Y equals x squared minus 4x is the equation of the parabola. Y equals x is the equation of the line. It looks like we have 2 points of intersection. A point here and a point there. A point at the origin. And over here at 5, 5. And finally, we have y equals x squared minus 4x. That's the upright parabola, the U-shaped curve, and then y equals negative x squared is the upside down parabola. It looks like we have 2 points of intersection right here and right here, and those points are 0, 0, and 2, negative 4. So now that we kind of have an idea in our minds of what we're working with, let's go ahead and solve a few of these problems algebraically. It says solve the following systems algebraically. Check the intersections using your graphing calculator if possible. Graphs have been provided so you can sketch the graphs if you like. I want to focus mainly on how to solve them today, and it may have been a while since you've used a method called substitution. And I'm going to recommend using substitution on this first problem. As a matter of fact, if we look here, we've got y equals in our second equation. Let's take the value that y equals, which is negative x plus 2. And let's put it back into the other equation where we see y. So it's going to be negative x plus 2, replacing that value of y, plus 8 equals x squared plus 2x. Remember what we're trying to do. We're trying to figure out where do these two graphs intersect. And in fact, I can pull up the calculator here. I might have typed them in already, and we can look at the picture. And it looks like I need to change my window. But there is the parabola, and there's a line. So we kind of have an idea of where they intersect already, which is nice that we can do that, and that's why it's nice to have a grid there to use as well. I'm just going to slide that in for now. But what we're going to do is we want to solve this equation. We want to figure it out algebraically. So if we look over here on the left side, we're left with negative x plus 10 when we combine these like terms. And over here we have x squared plus 2x. And the fact that we have x squared in there means that we need to eventually factor. So let's move everything over here to the right side of the equation. Keep that x term, or the x squared term, positive. It'll be much easier to factor. We get x squared plus 3x minus 10 equals 0. Well, now that we know that, we're going to factor. And the factors of 10 are 5 and 2. In fact, it's going to be plus 5 and minus 2, which ultimately means that x equals negative 5 and x equals positive 2. And what those are the x values of our ordered pair where our two curves, so to speak, cross. And usually what I do is I write negative 5 there in an ordered pair format and 2 in an ordered pair format. Because we need to go back into one of the equations and we need to figure out what does y equal. And when we look back at the original problems here, let's use the y equals negative x plus 2 for a couple reasons. One, it's not squared. y equals negative x plus 2. And what we're going to do is we're going to take that value of negative 5, we're going to put it back in this equation. So this is going to be negative 5 plus 2. Well, negative 5 plus 2, sorry, negative and negative 5 is positive 5 plus 2, 7. So there's our value of y. We put negative 5 back in there, so we need to make sure to put the 7 back in the correct order pair. But we need to do this twice. We have 2 intersections. So we're going to take 2 and we're going to put it back into the same equation. And you could use the first equation. It's a little bit more complicated. But negative 2 plus 2. And negative 2 plus 2 gives us 0. Once we've got our 2 ordered pairs, look back at your picture on the calculator. Does that make sense? Well, there's 2, 0. And if we're really looking, 1, 2, 3, 4, 5, negative 5, 7. Seems logical. Now, as we look at example letter B, we've got x squared plus y squared equals 25. Not as easy to put into the calculator. We would have to solve for y to put that back in the calculator. So I'm going to leave that alone for now. If you do remember how to graph it from Algebra 1 or Geometry or even Algebra 2, I think that could be helpful. But ultimately what we're looking at is how do we find these intersections of a circle, which is what x squared plus y squared equals 25 equals, and y equals x squared minus 13, which is a parabola. So again, I'm going to suggest that we use substitution in this problem. We're going to take this value of x squared minus 13. We're looking for x equals something or y equals something. And fortunately on this problem we have y equals again. So I'm going to take this value of x squared minus 13 and I'm going to put it back into the other equation wherever we see y. So this is going to be x squared plus, instead of writing y, we're going to write x squared minus 13 squared equals 25. Now remember, squared means times itself. So as we go ahead and solve this problem, it's going to be x squared plus x squared minus 13 times x squared minus 13 equals 25. So we're going to have to FOIL. And we've got x squared plus x to the 4th minus 13 x squared minus 13 x squared plus 169 equals 25. If we simplify this a bit, over here on the left side we end up with x to the 4th. We've got 1x squared minus 13 minus 13, which is minus 25x squared. And if we subtract 25 from both sides, we get 144. And now we need a factor. Well, x squared and x squared minus 16 minus 9 when we factor. And we could even factor a little bit more, but more than likely what people are doing is you're taking x squared minus 16 and setting it equal to 0. And x squared minus 9 and setting it equal to 0. So when you solve this, just a little bit of a warning here. We get x squared equals 16. And we're going to take the square root of both sides. When we take the square root of both sides, x is not just 4 x's plus or minus 4. 4 times 4 is 16. Negative 4 times negative 4 is also 16. Same kind of thing works here. Get x squared equals 9. Take the square root of both sides, and x equals plus or minus 3. So what this looks like is that we're going to have 4 intersection points. We're going to have a positive 4, and we're going to have a negative 4. We're going to have a positive 3, and we're going to have a negative 3. And I'm going to go back into the problem here and figure out what my other values are. And I'm going to So now we're going to take these two answers and we're going to put them back into one of the equations. The simpler one, most likely, which is the y equals x squared minus 13. And the nice thing is, on this problem, whether we put 4 back into the equation or whether we put negative 4 back into the equation, when we square that, when we put 4 back into the equation for x, we need a little bit more specific, and we square that, we get 16 minus 13, which is 3. But again, what it's trying to say, and I don't know if I'm saying it well enough, is if we square positive 4, we get 16. If we square negative 4, we also get 16. And regardless, 16 minus 13 is 3, which means that both of our values for 4 and for negative 4 are going to be 3. We need to do the same thing for x squared, y equals x squared minus 13 with the value of negative 3. And once again, when we put negative 3, or we put 3 back into this equation for x, and we square it. 3 squared is 9 minus 13, which is negative 4. But positive 3 squared and negative 3 squared are both 9. So when we finish up here, these two values here, 3, negative 4, and negative 3, negative 4, will also be 2 more points on this these intersecting curves. The circle and the parabola, in other words, intersect in 4 places. As we finish here, I actually used substitution on this problem as well. A little bit different from maybe what you did, but it says x squared equals 7 minus y. I took this value of 7 minus y and put it back into the other equation where we see x. So this is 7 minus y squared. Oh, nope, not squared. Because 7 minus y is being represented by x squared. So it's just 7 minus y plus y squared minus 4y plus 4 equals 25. The first equation, x squared plus y squared minus 4y plus 4 equals 25, is the equation of a circle. The second equation, x squared equals 7 minus y, is the equation of a parabola. But when we go ahead and simplify this equation a little bit, what we end up with is we end up with y squared minus 5y, combining these like terms. 7 plus 4 is 11 equals 25. And let's bring the 25 over to the other side. And we end up with y squared minus 5y minus 14 equals 0. So something to be really careful about. We're solving for y in this particular case. So when we write our ordered pairs, we need to put our answers in the correct spot. In other words, in for the y position of an ordered pair. So we're factoring y times y. And 14 is 7 times 2. And what we end up with here is y minus 7 equals 0, y plus 2 equals 0. And when we add 7 to both sides, we get y equals 7. When we subtract 2 from both sides, we get y equals -2. Those are y values. We need to come up with the x values now. But in terms of our ordered pairs, we've got that, and we have that. And we're going to go back into an equation and pick the simpler of the two, which is the x squared equals 7 minus y. So when we put 7 back in here for y, we get x squared equals 7 minus 7. Well, x squared equals 0. And when we take the square root, we still get 0. Over here with our -2, going back into the same equation, the x squared equals the 7 minus y. We're going to put that value of -2 back into our equation. So this is x squared equals 7 minus -2. So x squared equals 9. And when we take the square root of both sides, don't forget, the square root of 9 is not only 3, it's also -3. So it's +4 and -3. It means that we have 3 ordered pairs for our solution to our circle or parabola that are intersecting. It's 0, 7, and 3, -2, and -3, -2. We'll work some more on this later on in the week.